It's time for the Alien Conspiracy Podcast. We are your hosts, Agent Ether
and Agent Anderson. Come along as we examine UFO sightings, conspiracies, and all things strange. You can follow the show on Twitter at AlienConPod. We also have an email address, alienconpod@protonmail.com. We would love to hear from you. And don't forget to check us out on Discord, where you can say hello to the hosts of the show.
That's us.
This week's episode, Life in the Universe. Or is there life out there? Or, I don't know. What's a good title, do you think, Agent Ether? The Drake Equation.
It's more than just the Drake equation, though.
Etc.
I'd like to ask you, do you personally think there's life out there?
Oh, I think absolutely there is.
Intelligent life.
Yep.
And are they communicating with us directly right now?
Well, that's the real question now, isn't it? So did you want to start off with the Drake Equation, Agent Ether?
I want to start off with a joke.
All right.
How does NASA organize a party?
I'm not sure. How does NASA organize a party?
They plan it.
Oh, dear. Well, that's a pun for you.
I kill me.
Yeah, I know.
I can't help it.
Yep. You guys have no idea.
I am constantly sending our agent over here puns via text message.
And they are terrible.
No, they're very punny.
Yes, yeah, I guess so. I like there's one I sent her that says, it shows a picture of a guy writing on a piece of paper, my puns aren't just bad. Then he says they're terrible, and then he tears the page or something like that.
It's true.
Yeah, it's true. Pretty ridiculous.
That comes through many times. So anyways, the Drake equation. And the question is, what is it? And I like to call it a statistical guessing game.
Pretty much, yeah.
You plug in numbers and you see what comes out. So people may have heard of this. I think after Einstein's equation equals mc squared, it might be up there, but people might not be familiar with it and how it works.
It's kind of just like a thought experiment, really, is how I see it, because in order to calculate this, you have to make a lot of assumptions. You have to fill in data that we don't actually have. You're just assuming things.
And the point of the equation is when you multiply a bunch of stuff together, you get this value, let's call it N, the number of intelligent species that are communicating specifically in our galaxy, the Milky Way.
Yeah, so it's not looking for like microbes or plants or whatever. This is specifically centered around the idea of intelligent civilizations that have the ability to communicate with us.
And not just communicate with us in any way, but via radio waves.
Or some other means.
And this was named after Frank Drake. So in 1960, he started a project to search for extraterrestrial intelligence, or SETI, or Project OSMA? I think it's OSMA.
OSMA. I don't think I'm familiar with that one.
Oh, well, it was the first modern attempt to detect interstellar radio waves in the hopes of finding life in a far-off planetary system. And it took place in Green Bank, West Virginia, at the National Radio Astronomy Observatory. And his equation was used as part of an agenda for a meeting on the topic in 1961. Now, this was an informal meeting, and a bunch of big names were there. And the question they asked was pretty simple. Is it worth listening or not?
Right. And it turns out that they determined that it is, because we do an awful lot of listening. Even to this day, we're listening for radio signals from ET. And there have been some candidates over the years, one of which I'll talk about a little bit later.
So Drake himself estimated that the number N of communicative intelligent species was 10,000. But this was a long time ago when we didn't have as firm of a grasp on some of these values. And before we had things like statistical analysis and good, computers. So some of these things have changed, and I'd like to go over each of these values and talk about how to determine them.
That was my next question. What are the variables? Let's hear it.
So let's start with the value R. R represents the number of stars like our sun, which is similar in property, that form in our galaxy every year. And astronomers estimate this value might be around 1. So every year, a new star is formed in our galaxy, which is kind of like our sun. Then you multiply this by this value F sub P, and that means the fraction F of planets P. So the fraction of stars that have planets. And we're learning more about this each day. You're constantly hearing about planets being detected outside of our solar system. And some scientists think that half of sun-like stars have planets. We've detected thousands at this point, but still there's wild estimates, and they vary between, let's say you're very pessimistic, 5%, to very optimistic. Then it would be something like 90%, but let's just call it half.
Yeah, and I'd like to just point out that right away, if you're paying attention, you'll notice that there are some problems with this equation. For example, it supposes that life can only arise from a planet like ours and not a different type of environment, like let's say silicon-based life in a more harsh environment.
No, that's very true. That's why some people say the Drake equation is useless, but you're assuming there that it's some sort of scientific formula like Newton's law. But again, it's not. It's a thought experiment. Still, can you have life under extreme conditions in boiling hot water and sub-freezing temperatures? I mean, we're finding more and more that we can have bacteria in those kinds of, environments. So how do you really define that? How do you define intelligent life? We got dolphins. They're pretty intelligent. They're not able to communicate, but maybe there's some, dolphins on another planet.
Right. And maybe later on after your variables, we'll talk about more things like, possibility that life could be something or other that we wouldn't even recognize. But please continue.
So you're multiplying R by this factor F of P, and then you're multiplying that by N sub E, which is the number N of Earth's E, Earth-like planets, specifically planets that might have water. We're pretty optimistic about this value being high, especially if you can consider that planets can have water, but so can moons.
Right.
So Drake himself estimated this value is 2 based on ideas like the habitable zone, the range of orbital distance within which water can exist. But of course, that might have been too restrictive. And again, does life really need water?
Right. And also, like, when he did these equations originally, they had no idea how many planets there were out there, but more and more they're finding them everywhere. I mean, they're more common than they used to think. They're very common. They're finding so many of them out there that I think it's only a matter of time until they're able to detect at least primitive life or plant life or something like that.
Bacteria even.
Yeah, because that should have its own footprint on the planet that you'll be able to detect from a distance.
Right.
But so just to give you an idea of how many methods there are to detect exoplanets, one that I read about, which was very clever, was using the Doppler shift that the gravitational pull of the planet causes on its parent star. I guess we have sensitive enough equipment now to detect that shift. And not only that, there are some machines or methods you can do at home. You can just build your own little primitive observatory, probably with a Raspberry Pi, because that's what everything's built out of nowadays. But it's pretty incredible to me that they can detect it using such a simple method. I mean, the scientific basis for this method has been around for a very long time. It just nobody applied it to this specifically. Also, I'd like to point out that if somebody asks you some kind of astronomy question and you don't know the answer, just say the Doppler shift, because more often than not, that's the answer. How do we know the age of the universe? The Doppler shift? You are correct, sir.
Ding, 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 ding.
All right.
All right, so we're going to multiply those variables by another variable, F sub L, the fraction of Earth-like planets where life can develop. Now, we haven't found anything yet, but if you think all Earth-like planets might produce life, then your estimate here would be 1. So that variable would be 1. But if only 1 in 10 planets produces life, your answer would be 0.1. This is a complete guess, but it's something to think about. The universe is like, 14 billion years old, and Earth is 4.5 billion, and the oldest fossil is 3.5 billion. So the question is, how common are these conditions? And this is why it's important to look and hopefully find life on Mars to understand the likelihood of finding life somewhere else and helping us to narrow down some of these values, some of these parameters.
Right. And the idea is that if they find like life, even bacterial life or evidence of past bacterial life on Mars or Venus or something like that, then that suggests that life is actually common. But if they don't find life anywhere else in our solar system, then that supports the idea that it might actually be very rare. And there's different hypotheses. They call it the rare Earth hypothesis is one of them. But maybe we'll get into that later.
So you're multiplying these values together, the number of stars forming in our universe, in our galaxy specifically, the number of stars that have planets, the planets that are like Earth, and the planets where life might develop, any kind of life. Now, the question that comes next is what fraction of those Earth-like planets that have life on them actually have intelligent life? So if you think a planet of these parameters will always produce some species that has math and language and is able to communicate, your value here would be 1. Or maybe you think only 1% of these planets would have intelligent life, and then you'd have a value of like 0.01. So our life is pretty complex, but it developed pretty quickly on our planet, from an astronomical point of view. But it took a long time for us to get to a point where we can transmit with, let's say, radio waves. We're actually able to communicate and send out signals.
Yeah, but interestingly enough, if you look at the history of our race, we've had an awful lot of setbacks, times in history where things were advancing and then for whatever reason, maybe there was some really bad war
setbacks.
or like a big library got burned down and all of the collected knowledge of humankind was lost, stuff like that
happened.
It has happened. So if you imagine a civilization with similar capabilities to us, but they had fewer setbacks, they could have advanced much quicker. If they're, like we have these individuals throughout history that come up with these remarkable ideas that change everything, like let's say Newton or Einstein or somebody like that. If they had somebody like that earlier in their history that set them on a course to advancing their technology sooner than we did, then even somebody who, a life form that started at the exact same time as us, could have advanced much quicker. And for example, I've read that the estimates of how long we've been on the planet as people, somewhere in the ballpark of like 200,000 years, right? That's a long, long time. Like we could have definitely developed a civilization. There could have been a catastrophe and wiped everything out. And then we developed another civilization. That could have happened like 2 or 3 times already in 200,000 years. It's kind of interesting to think about. But the point being that, given the variables involved, it's very possible that another civilization could have developed much more quickly than ours.
Yeah, that's true. And so there's going to be this window where they can communicate with us. If you think about it, if intelligent life comes and goes, if civilizations come and go, for me, the question is, how likely is it that we are both in the same place as far as our civilizations are to where we can communicate with one another? And that's the next variable is F sub C. Can this, intelligent life communicate with us? And not only are they able to, but do they want to? Do they not want to? Do they all want to? Is this value 1? Is it 100%? We really don't know here. Your guess is as good as any scientist.
Right, because of the age of even just the Milky Way, let alone the entire universe, it's entirely possible that there is an intelligent civilization that developed millions of years ahead of us, or that will develop millions of years behind us. And that's kind of what you mean, right? By the window,
Yeah.
is that if it was here, even just 100,000 years ahead of us, somewhere out in the Milky Way galaxy, then it's unlikely we would communicate with each other. So it's kind of like looking for a needle in a haystack. It just would be one heck of a coincidence if an intelligent civilization just so happened to come about in a time frame to where we could communicate with them, because chances are it would be millions of years on one side or the other.
Right. So the variable F sub c is, can the intelligent life communicate? And then the next variable L would be the length of time, or how long the civilization is able to communicate. And that's it. Those are your factors. You multiply them all together and you get N, or, the number potentially of species within our Milky Way that are able to communicate with us.
Right. And again, it's a thought experiment because we don't know if a civilization has been around a million years ahead of us. Would they still want to communicate? They might be like, well, we've been there, done that. We've studied all the primitive species we want to, and we're kind of bored with this. We don't want to do it anymore. On the other hand, maybe they would want to communicate. Maybe they would want to reach out and say, hey, we are such and such. Come and join our space age religion, or, who knows what they would have to say.
So if you're having trouble wrapping your head around the Drake equation, because it is a lot of different variables, just remember, in the end, you want to know a number, a value, how many. So Drake himself actually asked his audience to think about this in a very specific way. He said, well, let's estimate the number of students at a university. You think about the number of new students coming in, your freshmen, entering each year, and you multiply that by the average number of years that the student will spend in school, 4 years, and that will provide a good estimate of the total number of undergraduate students.
Right. Okay. So that's a very similar idea.
Yeah, it's very similar. So the first 6 variables, when you multiply them together, give you an average number of new technologically transmitting societies that come online in the Milky Way galaxy each year. And you're multiplying this freshman rate by the equation's last term L, or the average lifetime they stay on the air. And your result is N, the average number of transmitting societies. So, if this number is small, then the chances of detecting a signal are also small. But if the value N is large, then, it's an incentive to press on with this search.
Right. So what are some plausible numbers that people have come up with throughout the years for the number of civilizations in the Milky Way?
I was going to write down these different values, but they vary so wildly, from 1 to, I think I wrote down, billions.
Yeah.
Values range from close to 0, fractions of a fraction, to a considerably positive value into the billions. But it's
billions of intelligent civilizations.
Yeah, but it's a guessing game. And that last term L depends on alien behavior. It's not a factor that we can quantify with astronomy or biology, and our own experience isn't going to help us very much. We've been transmitting on a wide scale basis and at frequencies and powers that might be conceivable to be picked up by someone in the solar system, but only for less than a century. So how long can we continue to do this before we find somebody who is receptive?
I think radio was, I'd have to look this up, but I think radio itself was invented in like the late 1800s maybe. But the signals would be so weak that they would have to have, an alien civilization would actually have to have a probe in our solar system to pick that up, probably.
Yeah, you have to think of it in terms of us actively transmitting, I think.
Yeah.
So,
which we have done on a few occasions, one of which I will talk about later.
SETI scientist Jill Tarter said the equation, and I quote, is a wonderful way to organize our ignorance. Kind of like that.
Yeah, it's nice. I like that.
Yeah.
But yeah, it's a totally fun thought experiment. You can look up, discussions and videos and all sorts of things on it. And at the end of the day, it's not something that you can say is a fact. It's just something, it's something for a good conversation, basically, you know?
Well, there was a recent paper, you may have heard about it, that revised the Drake equation.
I did hear about this because you told me.
Oh, yes. So you take the number of technological species that have formed from the history of the observable universe, and this equals the number of habitable planets in a given volume of the universe, and you multiply that by the likelihood of technological species developing on one of those planets. So let's see, they got these guys, Adam Frank and Woodruff Sullivan from the University of Washington in the astrobiology department. And they asked, what is the number of advanced civilizations likely to have developed over the history of the observable universe? Not solar system, but universe. And they say when they ask the question in this way, it eliminates the need for that value L, which is a huge unknown. And Sullivan said, rather than asking how many civilizations may exist now, we can ask, are we the only technological species that has ever arisen? This shifts focus, eliminating the uncertainty of the civilization lifetime question, and allows us to address what we can call the cosmic archaeological question. How often in the history of the universe has life evolved to an advanced state?
Yeah, such an interesting question, isn't it?
Yeah. So instead of calculating the odds against humanity to be the only civilization in the entire history of the universe.
And it's just sort of strange to think, well, if you look at the size of the universe, even just the size of the Milky Way galaxy, it's strange to think that we would be the only intelligent civilization out there, right?
Yeah, that's very true. And the result of his study, I didn't understand all the math, but in the end, he said he felt it was very, very likely that other civilizations had developed in the universe.
Well, yeah, if you're talking about the whole universe, has to be.
Yeah.
Has to be. It's just too dang big.
So he said we are only unique if the odds of civilization developing on a habitable planet is less than 1 in 10 billion trillion, which is a very small number. So he said he thinks that these species have evolved before.
Yeah, I think so too. I wonder how close to us they would be. You know, I used to think watching, like, let's say Star Trek or whatever, you'd be like, man, Captain Kirk, there's no way he could get with that alien lady because biologically speaking, we would be so different from each other that it wouldn't even make sense. But on the other hand, I thought about it a different way. I'm sure I'm not the first person to think about this, but what if, you know, you have certain elements, for example, right? Like gold is going to be gold no matter what the planet is, right? It's always going to be gold. Hydrogen is always going to be hydrogen. What if life always arises in a very similar way, and you need things like an opposable thumb to build more advanced, you know, technologies? And even if they don't look exactly like us, what if it's very likely that they're going to be some sort of like monkey-based life form, essentially?
Bipedal.
Yeah.
Man.
What if there are certain factors that are more common for, you know, intelligent civilizations, and certain types of animals, like let's say an octopus, are far less likely to become intelligent? Then once you think about it that way, you're like, okay, well, maybe Captain Kirk really is out there banging all these aliens, you know?
Maybe.
Maybe. You never know. All right. Is that what you had on the Drake equations?
The Drake equation.
What do you think, Agent Ether? Do you think there is life out there?
It's hard to say. You know, I want to believe in things like UFOs and people, you know, visiting us from ancient civilizations. At the same time, I'm like, well, they haven't come out publicly, you know? Mm-hmm. So it's just, it's hard for me to say. I mean, on this planet, are we being visited? I don't know. But out there in the universe, I just find it really unlikely that we're alone.
Right.
You know, we used to think that the Earth was the center of the universe, and boy, has that been disproven, you know? So maybe it's conceited of us to think that we're the only life in the whole, that it belongs to us, that the universe is ours.
Yeah, and it doesn't matter what we think. That doesn't form the reality of the universe, you know?
Right. So we're the most intelligent thing in the entire universe.
God, I hope not. All right. Well, to go hand in hand with the Drake equation, there's something called the Fermi Paradox. And the Fermi Paradox was it was an idea that came from a conversation between physicists Enrico Fermi, Edward Teller, Herbert York, and Emil Konopinski. In 1950, they were discussing some recent UFO reports and faster than light travel and some stuff like that. So the question that Fermi asked was, okay, well, if there's a lot of alien life out there, where the hell are they? Because they were coming from the perspective that all of these UFO reports were basically explainable as basically, misidentification of a weather balloon,
like
or
Blue Book, like Project Blue Book.
Well, I don't think they were specifically associated with Project Blue Book, but this was in 1950, so Blue Book was definitely going strong at this time.
So there was a lot of public talk and speculation about UFOs at that time, UFO sightings.
Yeah, and after 1947, the UFO topic became much more public, but there were a great number of sightings even before 1947 that just were not as in the public media as much. One that I'd really like to do an episode on is the Foo Fighters that were seen by pilots on, both sides of the war during World War II. It's a really fascinating topic, but we won't get into that tonight, unfortunately. We don't have enough time. But anyway, so the Fermi Paradox basically says, if life is out there, where are they? How come we can't detect them?
Where is it?
We should see a bunch of stuff out there from aliens, whether it's, probes or spaceships or whatever. Here's the basic line of reasoning for the Fermi Paradox. There are billions of stars in the Milky Way similar to the sun. With high probability, some of these stars have Earth-like planets in a circumstellar habitable zone. Many of these stars, and hence their planets, are much older than the sun. If the Earth is typical, some may have developed intelligent life long ago. Some of these civilizations may have developed interstellar travel, a step humans are investigating now. Even at the slow pace of currently envisioned interstellar travel, the Milky Way galaxy could be completely traversed in a few million years. And, since many of the stars, similar to the sun, are billions of years older, Earth should have already been visited by extraterrestrial civilizations, or at least their probes. However, there is no convincing evidence that this has happened. Now, let's not get into the obvious flaws in this line of thinking just yet. We'll talk about that in a bit.
I do want to say, though, that Fermi was one smart cookie. I was reading about his early life, and it gave me traumatic flashbacks of my time in graduate school. But unlike myself, he was an absolute genius, and the scope of his knowledge and abilities not only surpasses mine, but I would say anyone, like a lot of people.
On the other hand, I wonder if that would make a person close-minded, as if they already know everything, and if it's not if it's not something that lines up with their opinion, then it must be false, because they're like
I heard
really
he
smart.
Was a really great teacher.
Okay.
And I feel like people who are teachers, I don't know, I just picture him as having an open mind and being really excited about, science and possibilities. And if you think about the fact that he won the Nobel Prize and he's the father of the atomic bomb, is he really that conceited, or does he just have a brilliant mind?
Yeah, who knows?
Who knows?
I was just wondering that, because his position is that the UFOs, none of them are real, and that there's no evidence of visitation. But my idea was that maybe because he's such an authority that he's not willing to consider something outside of his own realm of experience. But anyway, so like I said, the underlying premise of this whole thought experiment is that the UFOs being seen all over the place at the time, and to this day, are basically not real. The scale and probability that we talked about earlier seems to favor that life is common in the universe, maybe not right next door at Proxima Centauri, but there should be lots and lots of it out there, right? But we can't find solid evidence of it anywhere. That is an actual probe or something. Even if only a tiny percentage of stars had life. There would still be a ton of life out there because there's so many stars in the galaxy and in the universe. The number I found was that the Milky Way alone has something on the order of 200 to 400 billion stars. Did you say the number earlier, Agent Ether?
No, I just said that possibly there were billions of civilizations.
Yeah. So, I mean, let's say that it's somewhere in the middle, like 300 billion stars. That's a lot of stars.
Man.
And the idea is that even if only, let's say there were 10 civilizations, but some of them developed, 10 million years ago, they should have colonized the galaxy by now. And if they colonized the galaxy, they would be everywhere, even in places that would not be normally habitable.
Habitable.
Man, I don't like that word. But yeah, they would be places even you wouldn't expect to find them. And that's sort of the idea here. So they have a name for this, that we are not special, right? That we talked about this a little, we touched on it earlier, but there's a name for the idea that Earth is not unique. They call it the mediocrity principle. In other words, that there are plenty of other civilizations out there. So I'm throwing out some of these terms,
sure,
in case some of our audience, they want to Google it themselves and read about this. This whole topic, like just the Fermi paradox, is a rabbit hole that links to so many other different things that can just take you in all these weird directions. It's a really fun one that I wish we had more time to to discuss it, but probably our audience doesn't want to hear 3 hours about the Fermi paradox and related topics, I'm guessing. So anyways, why haven't we found this stuff, right? So maybe intelligent life is extremely rare, and the lifespan of an intelligent civilization is very short.
We're going to find out, aren't we?
Yeah, right. And the chance of two of them existing simultaneously is very small, as we sort of touched on earlier. Maybe they're all over the place, but we can't detect them. Maybe they want to stay hidden. So these are some of the ideas behind the Fermi paradox. Like, why can't we find them all over the dang place like we should, right? So if we can't detect them, that might be because we're already, let's say radio's been here for about 100 years, and we're already leaving it behind. It's pretty much completely obsolete by this point. We don't really use it for communication anymore. So that could be one reason, is that, we're looking in the wrong place. It could be that they want to stay hidden, that they don't want us to find them. And a species with technology to traverse the stars could probably stay undetected, right?
Sure. I don't know. In a lot of movies, they can't, though.
Well, I mean, yeah. Independence Day, anybody? But so there are some possibilities of how we might detect these species out there, either in our own solar system or in other places. For example, we might be able to observe that they have mined asteroids for materials, or even planets to harvest materials for their own uses. Or another idea is that we could detect something like a megastructure, like a Dyson sphere, around another star that would be used to capture all of the star's energy, sort of like a bunch of solar panels circling the stars. But
that's a really advanced technology right there. Very theoretical.
But on the other hand, I think that these ideas are sort of counterintuitive, because as we advance our own technology, everything we do becomes smaller and smaller, right? Not bigger and bigger. Yeah. So I think that goes for energy sources as well. Think about, using coal power versus using gas power, and now we're going to electric power. So what if they were able to micronize nuclear power, but not just nuclear power, but clean and safe nuclear power, to something the size of a AA battery could power, a locomotive or something,
What do they use
or an entire city?
In Star Trek, some sort of crystal, dilithium
crystals, yeah, antimatter and all that good stuff.
That's a pretty big system.
Yeah. But the idea is, my idea is that a Dyson sphere, something that could completely encircle a star, that's pretty ridiculous if you think about the amount of resources that would take, when I believe that somebody more advanced than us would have a power source that would be, something the size of your little fingernail could power the entire planet or something like that,
Maybe
right?
even some sort of gravitational power having harnessed
Right.
gravity.
Who knows what
Who
they
knows?
would come up with, but whenever I heard about these Dyson sphere type deals, I always think, that just doesn't make any sense. Why would, like that somebody more advanced would put all the effort into building something like that when they probably have something way better. And also the same thing goes for mining asteroids. They probably would only need a very small amount of materials because over time, as their technology became smaller, it would stand to reason that they would either become smaller themselves or make themselves smaller. They would be able to, control their own DNA, if you will. And if you become more technologically advanced.
Wait. Are you saying there's a bunch of teeny tiny aliens wandering around the universe?
Yeah, kind of like in Men in Black, how you have that little tiny alien piloting that robot,
Really?
That little tiny guy in there. You don't remember that?
No, I remember it. It's just I find your idea unique.
Well, it's actually not. I mean, I've seen it at other places. This is not something I've come up with, but just think if you have a population explosion and you can make people 1/10 of their current size, well, that makes food production a heck of a lot easier, doesn't it?
I suppose. And now I'm thinking about what is it, Gulliver's Travels?
Yeah.
He gets trapped on the island with a bunch of little people.
But anyways, also if people were 1/10 of the size or even 1/50th of the size, you could fly around in a much smaller ship that would require much less energy, and it just, everything scales better as the species produces more and more offspring. It becomes easier to sustain that civilization if they don't need as many resources. That was just one idea I had, was just, how counterintuitive some of these things. So some people think that we should look for asteroid mining or Dyson spheres, but I think that those things are absurd because nobody's going to build. If you have the ability to build a Dyson sphere, you're going to have better technology, and you may even have the ability to synthesize matter itself, kind of like the replicators in Star Trek. So you wouldn't need to mine asteroids. You might just need a base material like hydrogen or something like that to convert to something else. But I mean, that's plentiful. You can get that anywhere. So you wouldn't need to go mine asteroids. So that the point is that they're looking for evidence of civilizations, but that evidence, what they're looking for, might not even be the correct thing to look for. That might not be the way to find them. There could be a ton of aliens in our solar system, and they're not going to be mining asteroids or building Dyson spheres, so we would never detect them because we're not looking for the right thing. So another very obvious thing about this whole thing is that if you've listened to this show before, you know that we are proponents of at least the possibility that aliens have been here. So one of the big problems with the Fermi Paradox is that there actually is evidence for visitation. It's just being covered up or ignored. And you can go through a great many number of cases that provide good evidence, like really, really good evidence that something strange has happened, that it was probably not a terrestrial ship, not a weather balloon, not any of that stuff, but there's a good chance it was extraterrestrial. So I feel like even in 1950, you had a lot of good cases, and there've only been more over the years. So I feel like one of the big problems with this is that, it's kind of funny because Fermi thought that we should have been visited many times throughout the years, but he just ignored, dismissed, or maybe wasn't even aware of all the cases of visitation, both before 1947 and after. And that's usually the cutoff, is 1947, even though it's sort of that the line blurs a little bit when you look at the history of it. But that's, in general, that's the modern UFO era, started in 1947. But I just think it's ironic that he's willing to discuss the possibility of intelligent life, but then it's the possibility of it having been here is like, nope, that's not possible. Couldn't have happened. Well, why not? I mean, just think about it for a second. So back in the day, it was an insurmountable challenge for us to cross the ocean. Now it's trivial, right? So a civilization millions of years ahead of us, maybe traversing the entire universe has become trivial to them, And we discussed on previous episodes, let's say for time travel, how from the perspective of a beam of light, something traveling at the speed of light, that can go anywhere in the universe instantaneously from its own perspective, right? Now, obviously, from our understanding of physics, there's a lot of problems with using this to travel, but That's not to say that somebody more advanced than us hasn't figured it out and is able to travel instantaneously anywhere in the universe. And if that's the case, if that's actually possible, then of course of course we've probably been visited. What do you think, Agent Ether?
I think I'm distracted.
By the cute little cryptid?
Yeah.
Oh, he's adorable.
Yeah, look at him.
Yeah, he is pretty dang cute. All right, so there's certain ideas that can also explain the Fermi paradox, assuming that we haven't been visited. Let's back up on that a little bit and say, okay, we haven't been visited. There's no evidence of them that we've seen. So what can explain the paradox? The fact that there should be tons of them out there, but we haven't seen any evidence for them. One of the explanations I mentioned earlier is called the rare earth hypothesis. And this is the idea that the Earth isn't average or mediocre, but exceptional, and that it's actually very, very unlikely for life to develop on any planet, no matter what the conditions are. And it's so rare, in fact, that, even though there might be other civilizations out there, they're going to be so rare that we'll probably never meet them. And that's kind of a sad story. We have no way of knowing for sure until we can explore, more of our own solar system or even other solar systems, which would be very exciting if that happened in our lifetime. I doubt it, but, one can always hope, right?
Right.
Another idea is that life is common, or maybe not super common, but intelligent life and civilizations with technology to traverse the stars, or at least to communicate, are very, very rare for whatever reason. They could, for example, experience extinction events periodically, such as planetary impacts, runaway greenhouse effects, gamma ray bursts, and on and on. There are so many natural ways, like even just solar flares. There's so many ways that a planet can be wiped out that maybe it's just very rare for a civilization to last long enough to develop higher technology because of, all these natural dangers. And even our own history, we know that there have been several such events on Earth. And one time I read about the genetic bottleneck, where they think that there was only 3,000 people left on the planet at one point. I mean, come on. That's crazy to think about it, that something caused everybody to get wiped out, except for that, such a small number of people that survived and carried on. Kind of scary too, if you think about it.
I don't like it.
I know. But so that's another explanation as to why, is that, there's plenty of life out there, just for one reason or another, it can't really develop technology. Another idea is that technological civilizations tend to destroy themselves. For example,
I believe this one.
Oh yeah, this one sounds plausible. Yeah. For example, there have been several close calls where we almost destroyed ourselves with nuclear weapons, some of which we've talked about on this show before. And that's just one possibility. That's just one technology, right? Just nuclear. So there's also things like global warming, artificial intelligence, bioweapons. There's a long list of ways that we could destroy ourselves, and climate change alone could explain the lack of civilization. So let's say every intelligent civilization reaches a point where they develop technology that starts to use a ton of energy, and this causes an inevitable warming that makes the civilization go extinct before they can figure out how to prevent it. So it could just be just a normal order that once you develop technology, there's a period where you have that technology, and then boom, you destroy yourself, and that could just be the normal thing that happens to intelligent civilizations.
It's crazy to me is a lot of people that I know are basically like, well, if climate change is real, we'll figure it out. Like, they're so confident that as a species, under any circumstances, we will continue to survive.
Right. And that's kind of scary, because if you reach a point of no return, maybe they would figure it out, or maybe it would take them hundreds of years to figure it out and they wouldn't have enough time.
Right.
It's pretty frightening. But the more frightening thing is the individual can't really do a whole lot. I mean, you can recycle, buy an electric car. I don't know. But, on the whole, there's not really a whole lot we can do to prevent it. We're just along for the ride,
It's true.
We'll just have to see what happens. And that's sort of where that one goes. And another sad story. I don't really like that one. All right. Maybe the first intelligent civilization in a galaxy attempts to exterminate all the others. for various reasons, such as maybe eliminating competition for some sort of, cultural or religious reason, maybe out of sheer paranoia or whatever. So that's another idea, is that they could, instead of, being friends, they would try to eliminate the competition. And they could do this with self-replicating probes. So that's an idea of why we don't see alien activity everywhere, is because the first to become smart and the first to develop technology actually killed everybody else. Another sad story, right?
Wow. Do you have anything positive you're going to bring up?
I mean, there's the Arecibo message. I'm going to talk about that later. That was kind of fun.
Okay.
We'll get to that in a moment, or a few moments. But I mean, yeah, I'm just going over, there's a lot of ideas that could explain the Fermi paradox, right? And some of these we've touched on already. So, for example, my next one is that a civilization might only be detectable for a very short time until they start, using technologies that are no longer detectable, either on purpose or by accident. So, like right now, even still to this day, even though it's somewhat obsolete, we're still broadcasting, a lot of radio waves out into the atmosphere that could theoretically be detected from a far enough point away from another planet if they had a very sensitive telescope, right? But that may only happen for a very short period, and then they move on to something else, like let's say fiber optic, which you're communicating through like basically a cable or a wire, and that there's no way they're going to detect that from another star. I don't see how you could possibly do that. Maybe if you had really sensitive equipment that could detect magnetic fields or something, I don't know. But it's not the same thing as broadcasting radio waves just out there for anybody to see, Another idea that I hinted at earlier is that maybe life, even intelligent civilizations, takes a form that we are unable to recognize, or is so different from us that we can't even communicate with each other. So, for example, if they experience time much more quickly or much more slowly than us, then we won't even be able to have a conversation, and we may not even recognize the intelligence involved there. Like I think I mentioned this we talked about this on a previous episode, actually. Like, what if, I don't know, a grove of trees is actually sentient, but, one sentence for them takes 1,000 years. So there's no way we would even recognize that they were sentient. That's just, maybe a stupid example, but the point is that there may be a form of life that we are unable to recognize, even if we're looking right at it. And that's why, even though the Fermi Paradox says that there's no life, there is life. We're just not identifying it correctly. If we detected a radio wave for a species that experienced life, 10 times faster, because our perception of time is a biological construct. I think it's possible that a life form could experience that, let's say, 10 times faster. So their radio communications might just look like background noise to us. It might not even look like an intelligent communication because it would be happening too quickly, right? We wouldn't slow it down to our time frame. So that could explain the paradox, that why we can't detect it is just because we're not looking in the right time frame. So they might also be so advanced that we can't even have a conversation with them. For example, think about trying to have a conversation with an anthill or a dog, right? Even if you could somehow speak their language, you wouldn't even really be able to have a conversation. You're on completely different wavelengths. Like a dog is going to be, concerned about smelling things maybe, and you're not going to even understand what they're talking about. They're not going to understand what you're talking about when you're talking about, your iPhone or whatever it is. And there's really no mutual understanding between those two species. So that's another idea that could explain, the Fermi paradox, is that we cannot understand each other no matter how much we would try.
I don't know. I think that you're downplaying my very special relationship I have with my doggies.
Oh yeah, they're great, aren't they?
I think that we communicate in our own way.
Oh, sure. All right, another possible explanation of the Fermi paradox is that maybe an advanced civilization wouldn't want to colonize the galaxy for one reason or another. And that kind of checks out too, because it would take a tremendous effort to colonize an entire galaxy, even if it did take millions of years. And, you might think, well, why would they want to do that? If they had a home and they were happy there, why not just stay there, And there's other ideas, like what if they developed a technology where they were able to leave their, their biological forms behind and basically become machines, then if they all became machines, they wouldn't need to take up a bunch of space to continue their civilization. They could do it in a very compact form. In fact, it might be so compact that we would not be able to ever to detect it, no matter what.
And yet, I think there's this human need to explore. If you think about how we've traveled around the world and how people even go on vacation. And they don't go on vacation next door, right? They want to go on vacation somewhere else. A lot of people travel halfway across the world to see things and be somewhere different.
Yeah. Isn't that so strange that people are willing to risk their lives to go to space, for example? Like, it sucks up there, man. You don't want to go to space. There's nothing there. There's no air, no trees. Can't grow food up there. Why would you want to go on there,
I guess it would depend on this other species' drive and if they're similar to us, and that they're interested in that exploration and expanding their knowledge about their solar system, their universe, our galaxy.
Right. And that's another possible explanation sort of that you've touched on there, is that maybe we have these traveling nomadic alien races that don't live on planets and don't colonize planets, but instead they live on, like a fleet of spaceships or something.
That would be so cool.
Yeah, but it would also be very difficult to detect.
But don't you kind of want to join them?
I mean, yeah, that sounds like a good time to me.
It's like a fun time. Just travel around the universe, bartering.
And even if they could only travel, half the speed of light, they could still traverse the galaxy. They could still do it. And for them, time would pass, like let's say if it took them, 100 years to traverse the Milky Way, for everybody else, that would be thousands of years or whatever. I mean, I'm not sure on the math on that, but for them, they could do it in a short period of time. And then for everybody else, the things would age much quicker. So they could watch as as everything evolved around them. If they didn't ever stop to say hello, maybe they just drop probes along the way as they go around and around in circles.
It makes me think that someday when we do develop our technology that allows us to go very fast, we're going to have a problem with relativity. You don't want to leave everyone behind,
Yeah. Well, unless they come up with something like the Alcubierre drive, which, sort of cheats its way into faster than light travel. But I think that science is still going to advance from where it is. And I think it's kind of silly to say that we've gone as far as you can go. I think that faster than light travel is possible. We just haven't figured out how to do it yet, kind of a thing. But maybe that's a little naive to look at it that way. But still, if you look at the history of science, just look at it. The history of science is the history of doing the impossible, essentially. So why would that not continue, as long as we continue making scientific advancements?
Right, I hear you.
Another idea about galactic colonization is that maybe it happens in local regions and not the whole galaxy. So instead of spreading and saturating everything, maybe they just do it in like a little neighborhood, which would make it much harder to detect compared to if they colonized, the entire thing. Okay, so you mentioned earlier SETI is looking for radio signals, right?
Yes, I did.
But maybe they're not looking for the correct signals.
Yeah, I was thinking about that.
Yeah, or we're not looking in the right places for these signals. So one thing that they do is they'll pick a particular frequency that is, let's say they like, what is it, 1420, which is the emission spectrum line for hydrogen or whatever, because it's the most common element in the universe. But what if they're not transmitting on that frequency, or what if they're transmitting in a way that we're not looking for? So that could explain the Fermi Paradox, is that we're not looking in the right places. Another thing along those lines is that maybe no one is transmitting and they're only listening, So that's what we do. We don't really transmit. We don't really send out signals to other places specifically trying to communicate. I mean, we have done that a handful of times, but mostly we're just listening. So what if everybody out there is just listening and nobody's really transmitting? So nobody's ever going to hear each other.
Another sad story?
Another sad story, yeah.
We're all out there and we're all ears.
Yeah. What if other civilizations have the fear of some sort of contamination either biological or even just the contamination of an idea. If, let's say, some sort of religious idea or whatever could transform an entire civilization. So maybe they don't want to contact others because of something like that. All right, now here's another one that you've probably heard of. It's called the zoo hypothesis. This one shows up in science fiction sometimes, like Star Trek, for example. The idea is that alien civilizations don't contact us to allow for our natural development. They don't want to interfere. Another variation of this is called the laboratory hypothesis, in that perhaps we are in some sort of, interstellar laboratory and we're being experimented upon. And of course, to do these experiments, they would not let us know about their presence. So the idea behind that is that either way, either if it's a laboratory or if it's just a zoo, in other words, that, we're sort of trapped here and we're being observed, civilization capable of traversing the stars should be able to observe us more or less undetected, because whatever technology we have, they would have had something similar, or they'll have something superior. So let's say if we have radar, and we're trying to detect them with radar, they would probably have a way of overcoming that and not being detected if they wanted to. And think of it this way: if we have little tiny security cameras that can be hidden in plain sight, then of course an advanced civilization would have the means of observation that are perhaps microscopic, or something that we would be unable to even comprehend, even if it was right in front of us. And this one is kind of crazy because it may maybe trigger some paranoia, but what if they had, some kind of camera that could be in the room observing you at all times, and you would have no way of knowing that it was even there? I mean, we can already pretty much do that to an extent, so somebody with more technology should be able to do something like that, to observe us without being detected. So the last idea that I have, you could go on and on with these discussions, clearly you could go on and on with this stuff to try to explain the Fermi Paradox, which kind of makes it fun, even if it's based on a somewhat shaky premise. But perhaps beyond a certain distance, the universe is just a simulated reality. And this is called the planetarium hypothesis. So whoever created our planetarium makes it look like we are alone in the universe. And it's sort of like a little fish aquarium, and outside of that, there's something that we're not even aware of.
That's very matrixy.
Yeah, it is very matrixy. Yeah, I thought that was kind of a fun one. But that's the last one I had to explain the Fermi Paradox. Let's move on to a couple of other items that I have notes on here, just to sort of talk about life in the universe, because I thought they were fun. On August 15th, 1977, Ohio State's Big Ear radio telescope was being used for SETI, the search for extraterrestrial intelligence, and it detected a strong narrowband radio signal from the direction of the constellation Sagittarius. The signal was discovered by astronomer Jerry E. Ehman, E-H-M-A-N, Ehman? I guess, Ehman. He saw it while reviewing data printouts from the telescope. So we're talking real old school stuff here. It would just print out piles and piles of paper, and then you'd have to review them by hand, looking for some sort of anomalous signal. He was so surprised by the signal that had been detected that he circled the signal and wrote "wow" in the margins. So this is known as the wow signal, which I'm sure anybody who's an aficionado of, aliens and all things strange has to have heard of this one, right? But maybe you haven't, so I figured I'll mention it. The wow signal lasted the entire 72-second window during which the Big Ear telescope could observe it, and it was only observed once and has not been detected since. It is considered an unmodulated signal, but any modulation with a period of less than 10 seconds or more than 72 seconds would not have been detected, so it very easily could have been a modulated signal, we just don't know it. At the time, this particular telescope was fairly primitive by today's standards, so the amount of data we're able to get from the signal is pretty limited. So a modulated signal is that's how we do FM radio and AM radio. We have a carrier wave, and then we modulate that wave to carry data. And it looks very, very different from a naturally occurring radio wave. An astronomical radio wave is going to look nothing like a modulated wave. They're very easy to tell one from the other. So that's why that's an important distinction. The telescope was limited to observing only any point for only 72 seconds because they couldn't really move it around or point it. They just pointed it in one spot, and as the Earth rotated, it changed where the telescope was pointed. And that window of observation was 72 seconds on the, because of the rotation of the Earth and the size of, what the telescope was looking at and that kind of stuff. That, along with the fact that the signal wasn't found until several days after the fact and not in real time, unfortunately, makes it sort of, I don't know, a lot more mysterious than it might have otherwise been, right? If they had detected it right away, then they probably could have pointed some secondary equipment at the spot and gotten a much better reading of the signal. But unfortunately, that's not the case. So we're left with this mysterious reading that we're not quite sure what it was, right? But a continuous extraterrestrial signal would have a particular signature. So they would expect it to register for exactly 72 seconds. And the signal intensity would increase for 36 seconds and then decrease for 36 seconds as the telescope passed by the location. And this is exactly what the WOW signal looked like. And that's why, people were so excited about it at the time, and some people still are excited about it. It looked exactly like what you would expect from a continuous extraterrestrial signal being seen by a rotating radio telescope. So the Big Ear telescope had two different feed horns, and both were pointing in slightly different directions. The WOW signal was detected in only one horn, but the data was processed in such a way that it isn't possible to tell which horn received the signal. As a result of this, we don't know exactly what the location was for the WOW signal. We have a pretty close approximation, but we don't know exactly because we don't know if it was the left horn or the right horn. So we can say it's one of two locations, but we don't know for sure where it came from. We can just check both of those places, I guess, right?
Keep looking.
Yeah, just keep looking. They've looked for it many times since, and some of these attempts to observe the signal again have been very, very recent, within the last couple of years. That's how interesting this signal was, is that they keep looking at this spot to see if they can detect it again, because this was probably the best signal ever detected from the SETI program, and it was probably the most likely source of an extraterrestrial signal. But they have rules that they follow, that if they cannot find the signal being repeated, then they consider that it's probably not extraterrestrial. They want something that's repeated. One of the ideas that could explain this is that an Earth source reflected off of some sort of space debris, and even Eamon himself believed that this was an explanation at some point. But if you look at the actual requirements of a space reflector to bounce the signal back and to have the properties that this signal had, it would be virtually impossible for that to be the case. So that's why many people say, even to this day, that this signal is unexplained and that probably did not have a terrestrial origin, even though it is possible. But terrestrial transmissions are forbidden at 1420 megahertz, which is where this signal was found, making it unlikely that it was our signal, but it could, of course, be an illegal transmission. But even if it was, there are ways to rule out terrestrial sources. Like, for example, this was not pointed at, Earth. The telescope was pointed to the stars. So yeah, there's no reasonable source or explanation to where this thing came from. And we're pretty sure it wasn't from the Earth, but they're not entirely sure about that. And it's just a really big, interesting mystery. It's a really fascinating topic that you could actually, if you want to get behind like some of the science behind it and stuff, you could go much more in depth to it. But that would require a lot of reading on my part. I don't fully understand the science behind it myself. So, I definitely didn't want to go down that particular rabbit hole, at least not for this week. So one idea that I had was that it could be some sort of alien probe that flies around the galaxy, pinging various planets to see if anybody sends a signal back to it. And this could explain why it was not detected again, because the probe came and it pinged our planet and then it left, right? And because it took us so long, on the order of days, to detect the signal and to look for it again, maybe the probe, it has so many different planets that it wants to cover. Maybe it only stuck around for a day or two and then left.
It was like, nope.
Yep.
Not ready.
Nobody home. All right. Peace out. So, I mean, that's one idea I had that could explain it. But of course, that's, purely speculative. There's absolutely no basis on that whatsoever. There's nothing to support it. It was just an idea that I had. In 2012, on the 35th anniversary of the signal, the Arecibo Observatory beamed a digital stream consisting of about 10,000 Twitter messages and some short video clips towards some of the candidate stars as a publicity stunt for the National Geographic show Chasing UFOs. And I just thought that was kind of silly. Like, wouldn't it be ironic if the first contact that we had was the result of a stunt, like a publicity stunt, basically? Like we send the signal and then we hit the probe. Like, what if the probe is in the solar system waiting for us to broadcast back to that exact spot, and it just broadcast once, and now it's waiting for us, and now we sent back this message and they get the message, and it's all just a publicity stunt anyways. I don't know. I was kind of tickled by that. The signal code that you can actually look up the printout of the WOW signal, and there's a signal code 6EQUJ5. This indicates signal intensity. So the intensity would be 1 through 10, and then after 10 it would use letters A, B, C, D, E, F, G, or whatever. And this is actually this is not like some sort of encoded data message or whatever. It just indicates the intensity of the signal as over time, as it went, as we swept through the 72-second window where we could see it. At its strongest, the signal was 30 standard deviations above background noise. I don't know about what's what, but that sounds pretty loud to me. What do you think, Agent Ether?
I think it was something.
Yeah, I mean, it was definitely not nothing, not a natural source, probably. That's for sure. And like I said, the frequency it was found at was 1420.4556 megahertz. And the reason why they look around 1420 is because that's the spectral emission line of hydrogen. And it's a very likely frequency to try to communicate with another species, because hydrogen is like the most common element in the universe. So if you had to pick a frequency, why not pick something like that, or the emission line of water or something like that? And if you're an intelligent species, you would probably look for something like that. And it was just to add one last thing, it was a narrow bandwidth signal that had a bandwidth of less than 10 kilohertz, which is also something that doesn't really happen normally from natural sources, although there are some that do have even narrower bandwidth than that, but we won't really go into those now. But it's definitely something only that happens in very special cases, not something that's very common. Usually it has a much wider bandwidth than that. All right, so that was the WOW signal. That was a fun one. I like that one because it's mysterious and it was probably not from Earth.
I feel like they parodied that in an X-Files episode.
Yeah, there have been. Yeah, it's shown up here and there in different places. There was one where I think they actually went to the Arecibo Observatory, right?
Yeah, I think so.
Was that the movie or whatever?
I don't know.
Let's not go down an X-Files tangent.
That's so good though. Actually, Agent Redacted was asking me, he's like, what's your favorite show? And I was like, of all time, like to narrow it down in my 43 years of life, like it definitely depends.
Edit. We're not that old. Edit.
And I told him, I was like, the X-Files is a pretty good show. And he's like, really? That's the one you choose out of all the shows that are out there? And in my defense, I actually don't watch that much television.
Right. But especially the early episodes, early seasons were really, really fun.
And I think they've aged well is the thing. A lot of shows don't, but I think they've aged well, so you can still watch them.
All right, let's get on. I got a couple more brief topics here. They're a lot shorter than the other ones, so let's get through them real quick. Just a couple of things I thought would be really fun to talk about on this topic. One of them is life on Venus. So on September 2020, research was published about the presence of phosphine in the atmosphere of Venus, and it was detected by the Atacama Large Millimeter Array Telescope. Now, phosphine should not exist in the atmosphere of Venus because it should decay fairly quickly because it'll react with like carbon and water and stuff. So it doesn't stick around in the atmosphere of Venus. But how is there phosphine there if it shouldn't be there? Well, this is one possible marker of life because it's associated with anaerobic ecosystems on Earth. So this suggests the possibility that the phosphine could be created by microbial life floating around in the clouds of Venus. And this was pretty recent, fellas. So just 2020, this is a pretty recent observation, although it has been observed, many decades ago. I think the earliest one I found was Carl Sagan, decades ago said that, there could be bacteria floating around in the clouds of Venus, but this is the first time they found actual evidence of that. So there are possible ways that phosphine could occur naturally, such as massive volcanic activity, but it seems like this isn't the case for Venus. As strange as it might seem, the most likely scenario appears to be that there is some life form in the atmosphere of Venus causing this phosphine, because you would have to regenerate the supply. You couldn't just leave, if there was an outburst of phosphine, it would go away, it would decline. But there appears to be a steady amount, right?
You could almost think of it as a marker.
Exactly, yeah.
So I remember when this first hit the news, and you know how the news is, the media, they kind of sensationalize stuff. And the headlines read more like, proof of life on Venus? But, in such a way to where it was implied that, yes, we'd found life on Venus.
Right. This is not proof of life by any stretch of the imagination. This is more of like a really interesting piece of evidence where they want to go and figure out what's causing this. Like, even if it's not life, it's still going to be something unusual that might still be interesting to look at, and it will help us understand our solar system a little bit better. But it could be life, and that's really exciting. Some people think that, so in the past we sent probes to Venus, where we basically just crashed the probe onto the planet,
Good for us.
And yeah.
Bully for us.
Some people think that the bacteria could have actually gotten,
contaminated.
Yeah, hitched a ride, and we contaminated Venus, and that's where this came from. That's one idea that's out there.
Yeah.
But a reevaluation of the data later on indicated that it's possible that the phosphine levels are lower than first thought, which would indicate a more natural level of phosphine and would not be a marker for life. But the possibility is there either way, and maybe it's a long shot, but Venus is, even though it's inhospitable, there are places on Earth that are similarly inhospitable to the clouds of Venus, and we have life in these places. So it is possible that there's life in the clouds, and there are plans to send probes to Venus, and maybe somewhere in the ballpark of 2028 to 2030 to go investigate further. That's not that far off, guys. So in less than a decade, we could have hard proof of life on another planet, even if it is just bacteria. And it may not be as much fun as an intelligent civilization, but I think it's still really exciting.
But instead, we're hunting around Mars.
Right. We've sent so much stuff to Mars.
So much stuff.
Actually, that brings up my next topic, the Mars rock thingy. That's why I can remember the name of it. So I just Googled Mars rock thingy, alien life or whatever, and it actually came up.
Yeah, it's amazing.
Yeah, it's crazy. These algorithms can be good sometimes not.
Right.
Anyways, we're talking about the Allen Hills 84001 or ALH 84001 meteorite that was found in Antarctica in 1984. And it's believed to have originated on Mars. I don't want to go into the science behind why they think it's from Mars, but it's pretty convincing. Like there are specific reasons why they believe it's from Mars.
I want a meteorite from Mars.
I know. How cool would that be, right?
Yeah.
That would be so awesome. You know what would be even awesomer? Is if I could buy this Mars rock on eBay and get them to make like jewelry or like a watch face out of it or something. That'd be awesome. Some people might say you're destroying, a natural artifact, but on the other hand,
you don't need that much.
That'd be like the coolest flex ever, right? You remember that meteorite that had alien life on it? I turned it into a watch. That'd be so cool. But anyways, So they had it since 1984. In 1996, a group of scientists found features in the likeness of microscopic fossils of bacteria in the meteorite, suggesting that they had originated on Mars. Because if it had been contaminated on Earth, then it would have only been like in the surface or whatever. But they found it embedded in the meteorite, which wouldn't have been able to happen if it had been contaminated on Earth. The discovery made international news, and even the president at the time, Bill Clinton, gave a speech about it, which is, I mean, that's pretty big deal. If even international news, if even the president mentions it, I don't know what he said. I should have looked up the speech, but he's probably said something like,
I bet it started with "my fellow Americans."
Yeah, we have nothing to fear. This is just a fossil. Don't freak out. I don't know. So it formed on Mars. One of the interesting things about this meteorite is that it formed on Mars when the planet had water. Again, we don't want to get into how they know this, but it's pretty solid that they're pretty sure that this formed on Mars while Mars still had water. It was blasted from the surface of Mars by an impact of a meteor about 17 million years ago and fell to Earth probably about 13,000 years ago. And they used, you can look up the images online, but they used electron microscope images that show these structures that look pretty weird. I mean, they might be natural structures, but they don't look normal. They look unusual, that's for sure. There's other Mars rocks with similar formations and evidence of life, but this is the only one that they found that come from when Mars had water on the surface. So that's why this is the one that the people are most interested in. So needless to say, this is very controversial, and they've done tons of analysis on it, and some people have found evidence of organic structures and compounds. Other people say it's all nonsense and it's just a natural formation. And there are camps on both sides of the argument, and it gets pretty sciencey, so I can't really go into the details because I don't really understand it myself. But if it turns out this is true, which who knows if they'll ever come to a consensus on it, then this would be the first ever extraterrestrial life that had been detected, which makes it kind of exciting. So yeah, go look that one up if you want to read, go down a rabbit hole and look at all this sciencey fact type stuff. But turns out we may already have evidence of life from Mars. It's just not conclusive at this point.
There's a lot of interesting stuff popping up about Mars. People are looking at images and extrapolating and looking at things here on Earth. And some people think that a long time ago, there was intelligent life on Mars.
It's definitely a possibility, It's definitely possible. And it would be hard to find these structures. There wouldn't be a whole lot left of them because it's been so long. They would be eroded over time. But who knows? Maybe some of these pyramid-shaped mountains, if you dig deep enough, you'll find some trace of civilization, I remember seeing a picture on Twitter that looked like a doorway that had been carved into the side of a hill or something, right? Do you remember this, Agent Ether?
Yes, I do.
It was pretty awesome looking. It looked like a doorway. Like, it did not look natural at all. But I guess it turns out it was only a couple of inches tall or something. And they say it was a natural feature, but
yeah.
I mean, they say it was a natural feature, but
tiny.
They can't prove that it was a natural feature.
Teeny tiny little aliens went in there.
Well, it might not be a doorway. It might be for some other purpose. Like we have little irrigation ducts that are that small, for example, But I mean, it's fun to look at those pictures and just think, what if this is an artificial structure, And we have no way of proving that or disproving it, explicitly right now, but maybe as our probes improve and stuff, we'll be able to get to the bottom of it.
Oh, there's so many photos you can go through of Mars. Like you could never get through it in your lifetime, just looking at all these pictures that they're,
Yeah, there are people who pore over these pictures and find anomalous looking things. And I really appreciate these people because I would never have the patience to do that myself.
Red rock, red rock.
And another red rock. But they come up with stuff that a rock that kind of looks like a lizard. Or there's one, my favorite one is it looks like a tree. It looks like a yucca tree or something. And it just looks totally bizarre. Remember I showed you that one, Agent Ether?
Yes, I remember.
It's very, very strange looking. It's not an artifact. It looks like an actual structure. And it looks like a plant or something. It's totally bizarre. But anyways, that's maybe a topic for another time. Let's get into the last topic I have notes on second to last is the object Oumuamua. This is the first interstellar object that had ever been detected passing through the solar system.
Oh, is this the one where a bunch of people committed suicide?
No.
Oh, good.
No, you're thinking about the comet Hale-Bopp.
I don't know. Am I?
Yeah, I think so. With that cult, the Branch Davidians, I think it was.
They thought there was like a UFO behind it or something.
Yeah, and then they bought this really expensive telescope.
And
then they couldn't see any UFOs behind it, so they returned the telescope. That's a whole other topic. Yeah, but no. Oumuamua was discovered on October 19th, 2017. So again, very recent development. And it was discovered by Robert Werk. How would you pronounce that?
Werk?
Yeah.
Werk?
Yeah, okay. I'll go with that. Its size was estimated to be between 300 and 3,000 feet long and 115 to 540 feet wide. And this, if you remember, was often depicted as like a cigar-shaped object, but we're not sure of its exact dimensions. We can only guesstimate. We didn't observe it directly. We were only able to observe its like brightness. Even with our most powerful telescopes, it was only just like a pinpoint of light. So as its brightness changed, we can infer its size and dimensions based on those changes in brightness, but it's only an estimation because we don't have direct pictures of it, unfortunately. We didn't catch it in time. By the time we caught it, it was like kind of already on its way out from what I understand. But we do know its like basic trajectory as it came through the solar system. It could also have been pancake shaped, maybe not cigar shaped. Now we'll get into this a little bit later, but if it was like a circular pancake shape, that's a little more interesting. The thing was colored red, which is similar to objects in the outer solar system maybe, but also it was more reflective and brighter than it should have been, which is kind of sus. It approached very close to the sun, but never developed a coma like a comet would. The Harvard astronomer Avi Loeb wrote a paper about the possibility that the object was an artificial solar sail, or maybe a piece of some sort of alien trash or something. And it was, I have here, it was 10 times more shiny than a typical comet. So very reflective, more reflective perhaps than a natural object would be. And the reason Avi Loeb thinks that it might be an artificial structure or piece of something was that it showed non-gravitational acceleration. So basically, as it was leaving, it sped up instead of slowing down. That's kind of weird, right? It shouldn't do that.
Yeah, that definitely breaks the laws of physics a little bit there.
Well, it doesn't break the laws of physics necessarily, but it behaved in a way that you wouldn't expect from a natural object, right? And we can get into the weeds in this, but we'll kind of hurry up. But basically, they think that the proponents of it being like extraterrestrial solar sail of some kind or junk or even a probe say that it couldn't have been caused by some sort of off-gassing because, first of all, we would have detected that. But also, the way the object was tumbling through space, it wouldn't really, if it had off-gassing, it wouldn't cause what we observed because of how it was tumbling, right? The origin of the object is unknown. If it was a natural object, it might have come from somewhere or other, but we're not really sure where it would have come from. While we were observing it, we did point radio telescopes at it, looking for unusual radio emissions, but unfortunately, none were found. But this goes to show you that even early on, astronomers were taking this very seriously as the possibility that it could be some sort of alien probe, because right away they started pointing radio telescopes at it, looking for weird signals. Of course, most scientists probably think that it was not an extraterrestrial thing. It was just sort of an unusual natural object with unusual properties. But there is a minority, such as Loeb, who believe that it was of or at least that it's possible that it was extraterrestrial origin. And if you want to know more about this topic, Avi Loeb has done a decent number of interviews, and he goes into great depth, and he makes a really strong case that it could have been an extraterrestrial object. There's a lot more detail to this case, but we'll move on for now. Maybe we'll revisit it later on and go into more depth. But for now, we'll leave it there. And we have just one more thing I wanted to talk about, which was the Arecibo message. Now, I wanted to mention this because we've only sent, as I mentioned earlier, we've only broadcast messages
to other civilizations or attempting to, the attempt to broadcast only a handful of times. And this is important to point out because if we're looking for radio messages, but we're not sending radio messages ourselves, that's sort of this catch-22 that how do we expect to detect them if we're not sending them ourselves? But anyways, the Arecibo message was broadcast towards the globular star cluster M13, 25,000 light years away in 1974 from the Arecibo radio telescope. It was sent only once and wasn't really intended as like a communication, but rather as a demonstration of technology. And I think it's ironic that they only sent the message once, because if we received such a signal, we would reject it unless we received it multiple times, right?
Right.
So it's just sort of ironic that, like I said, we're not really sending out communications. We're only looking for them, which just seems so strange to me that we wouldn't send out more. But I guess it does take an awful lot of resources and energy to send these signals to random points in space where it's very unlikely to be detected anyways. So, I talked about that earlier in the Fermi Paradox, how it's possible that maybe nobody's sending signals. Maybe everybody's only listening for them, because if you don't know where the receiver will be, you would have to send them all over the place. And that's not really feasible to do, at least not for us with our technology, right? The message we sent contains data that can be decoded to form what looks like basically a picture of, looks like an Atari game. I don't know. Have you seen this, Agent Ether?
Yeah, I've seen it.
Yeah, it looks like an Atari game, right? Like it's very, very crude.
Primitive.
Yeah, primitive looking. There were only 1,679 bits of data, and probably an alien race who received this, it's questionable that they would actually decode it in a way that it was intended to be decoded. But even if they didn't decode it the way it was specifically intended, they would still definitely identify it as an artificial signal, right? It would definitely be artificial because of the way it was sent. It was sent in bits of data, and that there's no natural source that could possibly look like this. The message itself was designed by none other than, drumroll please, Frank Drake, who we talked about earlier. Can you believe that? Drake actually designed the signal. How cool is that?
Go Drake.
Yeah, that's fun. And he had help from some other people like Carl Sagan.
I was in the back of my mind thinking Carl Sagan.
Yeah, you're like, that guy had to be involved somehow with this, right?
Yeah.
As skeptical as he was, his name pops up an awful lot with some of these alien topics, The data encoded a message, and it had the pieces of data that were, I should say, the data encoded in the message were the numbers 1 through 10, the atomic numbers of the elements hydrogen, carbon, nitrogen, oxygen, and phosphorus that make up DNA, the formula for the chemical compounds that make up the nucleotides of DNA, the estimated number of DNA nucleotides, the graphics of a double helix, the dimension of an average man, a graphic of a man. we're pretty liberal with the graphic of a man. It kind of looks like a guy, I guess, but the population of Earth, a graphic of the solar system indicating the origin of the message, a graphic of the Arecibo telescope, and the dimensions of it. When you look at the image, I don't really see very much of that stuff or any of that stuff. It's just looks like an Atari game. Like, I don't see any of this stuff in there. Even the numbers 1 to 10 don't look like the numbers 1 to 10. They're just like dots, right?
Yeah.
But
it's still cool.
Yeah, it's still cool. I don't think it would be decoded properly. And even if it was decoded properly, aliens would probably scratch their heads going, the hell is this crap? And be like, I don't know. But it does look artificial, I guess. That's the whole point. So the total broadcast of the message was less than 3 minutes. And the reason I want to point that out is, again, if you're looking for if another civilization was looking for us, they were pointed right at the sun. The only signal we sent was in the 70s for 3 minutes. What do you think the chances are that they're going to find that?
Right.
Like zero. There's no way they're going to find that. It's like a needle in a haystack, but I mean, not even. It would be much easier to find a needle in a haystack, I guess, is what I'm trying to say. They chose the number 1679 because it's a semi-prime number, or the product of two prime numbers. and it was sent in binary numbers. So again, if it was found by another civilization, it would be very, very obvious that it was an artificial signal. In 2001, a response was received to the message. A crop circle near the Chilbolton radio telescope in the UK was found. The response is almost identical to the message, but the human figure is replaced by what appears to be, a gray alien. I think it was not necessarily gray, but like that shape where their head is sort of enlarged versus ours. And the telescope at the bottom is replaced with a crop circle that appeared in the same field a year before the answer, which is really cool and exciting, but unfortunately it turned out to be a hoax.
Yeah.
But I thought it was fun, so I still mentioned it. It was still, if you're going to do a hoax, you might as well do it right,
That's right.
So I thought that was, even though it was a hoax, it was still a lot of fun. So yeah, that's all we had. There are so many more topics we could go into for life in the universe. Like, for example, we didn't even touch on, they think that there's life in, what is it? The moons of Jupiter or Saturn.
Yeah.
Stuff like that. And then
Io and so forth.
Yeah. Talking about the possibility that extraterrestrial life could exist in environments that we're not even considering, like let's say on the surface of Pluto or something like that.
Hell, in like the atmospheres of the gas giants.
Right, exactly. So this is a topic, like, I know we say this a lot, but I feel like you could probably do a whole podcast just on life in the universe or in other places, just on that. Like there's really that much to it. I was expecting to touch on a lot more topics, but once I started looking at just the Fermi Paradox and realizing how much there was to just that one topic, kind of went down a rabbit hole there. And then I didn't get to nearly as much as I thought I would, because there's just so much to it. But yeah, so we're going to call it quits for this week. Thanks for listening. If you enjoyed the show, you could really help us out by suggesting the show to your friends and leaving us a good review wherever you listen to podcasts.
Keep it strange.